Hello, Math 153 students. I would like to discuss problem 13 from homework 1. Had a few questions about it and I thought I should go over it with you. So it says to evaluate this series, and it gives you a very nice hint that does kind of does the partial fractions decomposition for you. If you forget partial fractions decomposition, you should review that. So what we have here then is the series from n equals 1 to infinity, the sum of 1 over 2n minus 1 over n plus 1 plus 1 over 2 times n, quantity n plus 2, right? Now, the best way to think about this, in my view, is to sort of break it up into three sums. So by the rules of summation that you probably studied in Calc 2, we can break this up into the first summand, which is 1 over 2n, so I can put a 1/2 out front, and it's 1 over n. And then minus the sum from n equals 1 to infinity of 1 over n plus 1. And then plus another 1/2 out front, the sum from n equals 1 to infinity of 1 over n plus 2. Now, you might be thinking, okay, well, that's great. How does this help me compute the sum? Well, the next step really is to uncompactify this or expand the sum, right? So this summation notation is saying a lot, right? There's an infinite number of terms here. Let's sort of write out what that looks like for the first one. It's 1/2, right, times 1 plus 1/2 plus 1/3 plus 1/4 plus da 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 towards infinity, right? And then minus the sum. Notice this is 1 over n plus 1, so the first term will be 2. The first denominator will be 2. It's 1 over 1 minus 1/2, right? It's 1/2 plus 1/3 plus 1/4 plus da 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 da, right? And then plus again 1/2. And now we're starting, we have an n plus 2, so it's going to be starting with a 1/3. So it's 1/3 plus 1/4 plus da 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 da, right? Okay. So right away we can see some things are going to cancel out, right? So the first thing I would do is sort of distribute maybe this 1/2 just to the first two, right? And I would say, okay, well, that's 1/2 times 1 is 1/2 plus 1/4, right? And then it's going to be plus 1/2 times the rest of it, which is this 1/3 plus 1/4 plus da 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 da, right? So that's this first guy. Now the second one, I'm going to what I'll do is I'll just take out the 1/2, right? And I'll say, okay, this is really a minus 1/2, and then it's going to be excuse me, not plus, it'll be minus then, 1/3 plus 1/4 plus da 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 da, right? And then the last one I'm going to just leave the same. So that's plus 1/2 times 1/3 plus 1/4 plus da 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 da, okay? So now what I want to do is, first of all, I can combine this whole sum and this whole sum, right? Because it has the same, it's the same thing. It's 1/2 of this plus 1/2 of this, so that makes 1 whole of that, right? So really we have 1/2 plus 1/4, and there's a minus 1/2 here, minus 1/2. And then it's going to be plus 1/3 plus 1/4 plus da 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 da. And then minus 1/3 plus 1/4 plus da 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 da, right? So you can see that these two infinite sums will cancel out because they're the same exact thing and you're subtracting one from the other. And then this one, we have a 1/2 minus a 1/2, which is 0. So this whole thing just equals 1/4. Okay? So it helps to, well, it helps to expand the sums and then simplify and then cancel any of the like terms. Now, you didn't have to do it this exact way. You might have had another way to look at it, which is totally fine as long as you have the correct method and solution. So hopefully this helps. Let me know if you have any questions about this problem. Thank you for watching. Bye.